Welcome to week 8, chapter 7 homework with a little bit of chapter 8. I'm going to do a different kind of video and just briefly go through all the different homework problems. Since this is a slightly different week where our math homework problems are sort of review, then let's just sort of go through them all just a little bit, get you started. For 7.1, we're doing some geometry ones, trying to find the volumes. For number 9, we have a rectangular carton. So I'm going to try and draw a rectangle, and we have 3 different lengths. One side is 21.3 centimeters. Another side is 24.2 centimeters and a height of 6.5 centimeters. Finding the volume isn't hard at all. We're going to find the area of this bottom thing, multiply together the length times width, and then we'll multiply it by the height to be done. We've done examples of that. I think you can take it from here. Problem 21 is similar. The barbershop pole also has a base and then a height. So we're going to find the area of the base and then multiply it by the height. This time it gives us numbers that the diameter is 6 inches. So let me draw this circle again. Diameter is all the way across the width of the circle, and that's 6 inches. The height is 24 inches. Okay, so we got that here. My little inches don't look like inches, do they? So I'll just do that. Okay, I don't want a diameter though. If I have a circle, what I want is the radius, because my area for a circle, what I need for the bottom of my cylinder before multiplying by the height, that area is going to be pi times the radius squared. So if it's 6 inches all the way across, then it's only half of that, or 3 inches from the middle to the edge. So the 3 is what I'm going to plug into here. 3 times 3 is 9. 9 times pi gives me this, and then multiply by the height. I think that's enough to get you started there. 7.2 is different. Now we're not doing volumes, we're doing unit analysis. And we're just slamming rates together until we get what we want, and then we can stop. So I have 0.85 grams per 1 liter, and I want to get milligrams per milliliter. So can I go from grams to milligrams? Sure, I know that one. There's 1,000 milli of anything in the thing. 1,000 milligrams in a gram, 1,000 millimeters in a meter. So, okay, that gets rid of grams. I'm into milligrams, which is what I want. How about milliliters? I can do that too. I can get rid of liters. If there's one on the bottom, I'll put the other on the top so they cancel. And I can go into milliliters, same as before. 1,000 of the milli thing makes the normal thing. Multiply across the top, multiply across the bottom, and we'll be done. In this case, we can just see that the thousands are going to cancel top and bottom anyway. So we're going to wind up with the same number we started with, which is not very exciting, but such is life. You can see a general trend here. If I have something without a metric prefix, an SI prefix, grams, liters, and I put the same prefix on both, it doesn't change the number I have. Okay, these I'm not going to do all the way for you like I just did, but we should just start setting things up and see how it works. So we have an order of 0.4 micrograms per square meter. MC, if you're not used to it, is micro as opposed to M, which is just milli. And square meter, if you didn't read it yet, is talking about how much surface area the person's skin have. If you cover them with stickers, how many stickers would it take to cover their skin? This is obviously estimated because we don't get to have that much fun at the doctor's office. Side note story, when my 5-year-old went for his COVID vaccine, to keep the kids happy, the check-in people were giving out stickers instead of just getting the sticker after your shot. And since my 5-year-old hates shots, he took 2 stickers and put them on the top of his arms to block where the shot would go. Anyway, so we need to get rid of micrograms. We need to get rid of square meters. What are we looking for? We're looking for how much of the drug will be administered. So that's going to be going to wind up with the milliliters. Let's watch what happens. So we can go out of micrograms and into milliliters. That's this one here. We can go out of square meters. That's just the 0.3 here. That's the one that's not a rate. Remember, we're allowed to have one of them that's not a rate. And often we rate that one first, but it doesn't really matter. And then when we're done, we're going to wind up with milliliters once we multiply. I guess I should fill it in for you. So we had 1 microgram per 10 milliliters. So we do everything and we'll wind up with milliliters. 53 is similar, but they're hiding something. They talk about 1 capsule TID. You have to go back to page 202, chapter 6.6, and it tells you that TID means 3 times per day. So you will need that rate as well. 3 capsules per day. In other words, this thing here will become the rate, 3 capsules in 1 day. Then you can see we'll have capsules canceling with capsules. And we'll have to change grams into milligrams, just like we did here. So those are the rates you'll be using. Number 57, same sorts of things. We have milligrams of drugs per kilogram of patient weight. Now, instead of their surface area of their skin, how much they weigh, but we're told how much they weigh, and we're told a rate of how many milligrams per 1 capsule. We'll put all those 3 rates together. Let me write them down again, just to be clear. We have 2.5 milligrams of drug per 1 kilogram patient. We have the patient's weight of 68 kilograms. So we're going to take that and put that over 1, since it's not a rate. And we have a rate of 50 milligrams of drug over 1 capsule. I purposefully wrote this wrong with milligrams of drug on top both times. So at least one of these rates you'll have to flip to make everything cancel nice. You can handle it. There we go. 63 is very similar. 65, now we're talking about molarity. Remember that molarity means moles per liter. That's what we want. So what do we know? Well, we know from over here, we have 32 0.04 grams per mole. And if we want moles on top, I better put that moles on top. Now we need to get out of the grams because we want liters. So can I do something from grams to milliliters? Sure, they tell us that 6.5 grams are in 500 milliliters. Oops, but I have it upside down. I have grams on the bottom both times because I am. Okay, now my grams will cancel. See, it self-corrects. But I don't want moles per milliliter. I want moles per liter. That's what molarity means. So I have to get out of milliliters and into liters. Again, milli just means 1,000 of these things in one of the other ones. Now I will have moles per liter once I'm done multiplying everything, and you can finish it up. The last two are just calculator problems. We want to find the log of 0.00000001. I can do that on my calculator. So I will say log of 0.12345 and then a 1, and it says -7. All the log tells me is that we have 7 decimal scoots, in this case in the left direction. So that's it. If I am using the Windows 10 calculator, let me open that, share to that. Then I'm saying 0.123456 and then a 1, and then I hit my logarithm key and it does the same thing. So there's not much to write here. We just pushed it in the calculator. The pH is the same thing, but the thing we're putting in the logarithm is a little more complicated, and we have to take the negative at the end because the pH is the negative of the logarithm of the molarity. So if I'm using the Desmos calculator, I'll just take this 2.512 and take the logarithm of that. 2.512. And then for the times 10 to the -7th, on this one, I just have to actually write that out. Times 10 to the -7. And here we go. It's like -6.6-ish rounding. But then when I'm done, I have to take the negative of this. So I'm going to take the negative off the front of it because the negative of the negative is positive. And I get about 6.6. If I'm using the Windows calculator, let me switch again to that. Then it's a little more awkward. I'm going to have to put in my, it doesn't have parentheses, so I have to do, well, it does, it just isn't happy about it. 2.512, and then I go exponent, not as the y to the x exponent, but the exponential form, scientific notation. -7, so now I have my number. Then I can say, let's take the logarithm of that, and then I can say, let's take the minus off the front. And again, we get about 6.6. So either way, it's just punching things into the calculator. On our website, when you want to learn about what all that really means, that's why we have the very cute picture, the angry chemist, now with even more jokes than this morning. Hope you enjoy this essay. Okay, that's all. Hopefully that gets you going on your homework if you were stuck.